Hey everyone, welcome to The Explainer. So today, we're diving into a truly monumental shift in the Linux kernel ecosystem. We are talking about the complete, absolute removal of a legacy C library function in Linux 7.2. Whether you're maintaining custom drivers, building out massive server infrastructure for modern AI workloads, or, just compiling out-of-tree modules, this is an update you absolutely cannot afford to ignore. We are performing a full autopsy on the death of strncpy.
Okay, let's dive right into this. You might be thinking, well, it's just one function, right? How hard could it possibly be to delete? Well, the answer is 362. That is the exact number of individual patches it took to rip this API out of the kernel. This wasn't just some single quick keystroke by Linus Torvalds. No way. This was a massive, highly coordinated engineering effort spanning across networking, storage, drivers, and literally the core kernel itself.
So why go through all that trouble? Well, this quote from Michael Larabelle at Fornix really hits the nail on the head. He notes that strncpy has been a persistent source of bugs for years. And honestly, when you're dealing with the absolute foundation of modern computing, an operating system that runs everything from your smartphone to massive enterprise AI clusters, leaving a dangerous, outdated API just sitting there unchecked, it was simply no longer an option for the kernel maintainers.
All right, here's our roadmap for today's explainer. 1. The end of strncpy. 2. Why strncpy was flawed. 3. 6 years of deprecation. 4. Out-of-tree code impact. And finally, 5. How to migrate safely.
Section 1. The end of strncpy. So the deprecation phase is officially over. Linux 7.2 completely removes strncpy from the kernel API surface. It is completely gone. If you're a developer building against Linux 7.2 headers or you're compiling out-of-tree modules against the specific release, this standard C library function is simply no longer available to you. The header guards have been dropped and the public surface is wiped entirely clean.
Section 2. Why strncpy was flawed.
Now, you might be wondering, what's with all the hostility towards a standard string function? Well, the biggest culprit here is the null termination bug. strncpy just has these incredibly counterintuitive semantics. See, if the source string perfectly fills or even exceeds the destination buffer, strncpy actually doesn't automatically append that absolutely crucial null terminator. That means the next time the kernel tries to read that string, it just keeps reading straight off into memory. It's like a runaway train, creating massive security vulnerabilities and system crashes.
But wait, it wasn't just a security risk, it was also a massive performance drag. strncpy copy suffers from what we call redundant zero filling. Basically, if you have a small string going into a really large buffer, strncpy copy needlessly fills the entire rest of that destination buffer with zeros. And in a high-performance environment like the Linux kernel, those wasted CPU cycles really start to add up across thousands and thousands of calls.
Moving on to Section 3. 6 years of deprecation.
As you can imagine, ripping out a foundational C function isn't an overnight job. This was a massive 6-year deprecation cycle. Year 1 kicked off with initial warnings. Then, years 2 through 5, those were the trenches. We're talking auditing every single subsystem, verifying call sites, replacing them, and making sure all the weird edge cases were handled properly across those 362 patch submissions. And finally, in year 6, we hit total removal in Linux 7.2. It takes an immense amount of coordination with downstream distributors and hardware vendors to safely execute an API change of this scale.
Section 4. Out-of-tree code impact. Okay, so who is actually broken by this update right now? There's a pretty stark contrast here. In-tree code, meaning the core kernel itself, is perfectly safe, fully migrated, and compiles cleanly. It's already using all the modern alternatives. But on the flip side, out-of-tree code is in some serious trouble. Maintainers of external code are facing immediate build failures, undefined references, and totally broken header guards.
To get specific, if you're working with DKMS packages, proprietary hardware drivers, custom subsystems, or really any build system pulling headers directly from /user/include/Linux, you are right in the danger zone. You're going to start throwing implicit declaration errors left and right. Actually, even build reproducibility is completely broken for projects that previously tried to patch kernel headers just to forcefully re-export strncpy.
Which brings us to Section 5. How to migrate safely.
So how exactly do we fix this? Well, here is the cure for out-of-tree developers. And this brilliantly illustrates the shift.
Back in Linux 7.1, to safely use strncpy, developers had to do this really clunky manual assignment, explicitly setting that last byte to a null character just to avoid those nasty memory errors. But now, in 7.2 and beyond, it's just a single clean call to strcpy. It natively guarantees null termination, and it simply will not write past the destination buffer. It's so much cleaner.
But strncpy isn't the only tool in your new arsenal. Think of this as your cheat sheet for modern Linux string APIs. You're going to use strncpy for your standard null-terminated destinations. Now, if you actually want that zero padding behavior we talked about earlier, you'd use strcpy_pad. For non-null fixed-width fields, you've got str to mem_pad. And finally, for bounded copies with explicit padding, there's mcpy_pad. The whole idea here is that the kernel now gives you precise, purpose-built tools instead of just one flawed catch-all function.
I do have to give you a vital warning, though. You absolutely cannot just do a simple find and replace across your codebase. strcpy returns the number of characters copied on success, or, and this is the key part, a negative error code on truncation. You really have to update your conditional checks to handle that negative return value properly, or you're going to run into issues.
Also, just a quick aside, if you are historically using strncpy purely as a sort of hacky way to validate string lengths before doing a copy, well, stop doing that. The modern, actually kernel-safe way to handle this is to just swap directly over to strenlen. It's exactly what it's built for. So, the crucial point to take away is this precise three-step workflow. Step 1. Replace your direct legacy API calls with strncpy or one of its variants. Step 2. Adjust your conditional logic and error handling to catch those new negative return values. And Step 3. Update your build configuration. You need to make sure your KDIR or kernel release variables are pointing to a 7.2 or newer source tree. Oh, and definitely don't forget to run make clean before rebuilding just to clear out any stale object files.
Which brings us to the ultimate question to wrap things up. Are your legacy out-of-tree modules and proprietary drivers actually ready for the Linux 7.2 upgrade? Because the deprecation warnings are gone, the API has been removed, and the deadline has officially passed. Now is the time to check your dependencies, update your C code, and run that rebuild. Thank you so much for joining me for this explainer, and happy coding.